Hey there everyone, in this video I'm going to explain different Kubernetes resources in order to make an application with Postgres database, and also I'll show how to persist data. And also I am going to make, actually it has already been made, but I'm going to show you how you can have a Razor page application. The Razor page application is only to show that the functionality, how everything works together. Basically, alright, because I have made some changes, I need to push it again, but actually I can go ahead and show you how this works in the first place. Basically, there is a Razor page in place. So I'm using Visual Studio and I'm using .NET 8. Basically, as I said, this is just a sample application. The main point is to show the functionalities of Kubernetes and how we can have the application deployed in Kubernetes. So I have a couple of models, a product model and also a category. This naming also needs to change, but anyway, so I have a category and I have a product. There is a one-to-many relationship between these two. I have used data annotations in order to show that, so basically how the whole thing works. I have used basically, where is it? Let me show you in the dependencies. Entity framework, I have installed multiple packages related to entity framework, like entity framework tools, relational design, etc., and the entity framework core itself, and also another one which is for Postgres, because the database that I'm going to work with is Postgres. After that, I have basically a couple of pages, one for category and also one for products. So the category page includes basically, yeah, there is a binding, and in the category page I am going to, on post, I'm going to add the category, and then I'm going to redirect. After successfully adding it, I'm going to redirect to the index page of the category. And in the index page of category, as you can see a table, and in this table I am going to loop into the category and then get each of the categories and show them. So also let me show you the front end of the other one. Basically there is a post form, and on submit the whole form is posted, and because it's a Razor page, here we have on post async. Maybe one point that can help during the development, in the same basically namespace, you cannot have both on get and on get async. You can only have one of them, or on post and on post async. Same logic for basically products. In products, again, we have a form group in order to basically post everything that is related to the product, which is the product name, and also choosing the category. And inside it, again, the same logic. There will be some validations happening, and after the validation, the product is being added, it's being saved, and it's being redirected to the index page. And in the index page, you have basically you have all the products inside a table. So this is the header, and then inside the body, inside each table row, you are looping around the products, and yeah, that's the index one. And then in the main index one, I have put two links to A tags in order to get and to redirect to the main page. Basically, this is where we see everything. All right, that's it. Then this is one point. Now, in order to make sure that this works. Now, this error that you see here is because of the database is not initialized yet. So basically, we have a database, but the database is not initialized. I can show you how the whole infrastructure looks like. Basically, here we have a Postgres. I have a config map for Postgres. Basically, config map and Kubernetes secrets are used in order to save the environment variables inside them. This is not, of course, this is wrong. I mean, wrong in the sense that it's only for development purpose, but password needs to be saved inside a Kubernetes secret, not inside the config map. And the other thing is that we have a persistent volume. Persistent volume, I mean, there are 2 points about here. One is that I wanted to show that if, depending on our DevOps policies, we can either let Kubernetes itself create everything for us. So basically, whenever we need to have a persistent volume, if we put the storage class into manage CSI, it can go ahead and create the resource for us. Or if the Azure, if our DevOps policies enforce us to use only the resources that we have provisioned ourselves, like for example with Bicep in this case, or with Terraform, in that case, we need to force the persistent volume to only use the resources that we already have, just like here. So I have a persistent volume, and this basically I give it a name, some labels. These labels need to be the same when we make use of it in the persistent volume claim, because I want to force it to use one of the resources that I have myself. I am using Azure Disk, and I put the storage class name empty. I put the storage class name empty, and then I say that okay, I want to have an Azure Disk. Then this is the ID of the Azure Disk that has been created with Bicep. And because it is Azure Disk, it can only be attached to one node. So basically, if I want to explain this, it looks like this. My Postgres pod requires to have access to, needs to be saved. I mean, we need to persist the data, because if the pod goes down or for whatever reason, we don't want to lose the data. So that's why we need to save it somewhere. It can be a file storage, or it could be an Azure basically managed disk. If it is a managed disk, it is read write once. But if it is a file storage, a file share from Azure Data Lake storage account, it can be read write many. For disk, for databases, because it's a transactional database, read write once makes more sense. And then so we have a pod. In the pod we mentioned the persistent volume claim, that we claim we need to have persistent volume. Then we have the persistent volume, and via the persistent volume, in this case, as you see, we are binding our persistent volume to some managed disk. Because it is a managed disk, it is read write once. And persistent volume can only be attached to one node at a time. And if it needs to change, it needs to be detached from the node and attached to another node. And here I am referring to the node pool that is behind the Kubernetes cluster. If we set this storage class name to manage CSI, we are letting the AKS cluster itself, that on the fly, whenever it's needed, creates a managed disk and attaches to one of the nodes. So this is the whole point of the storage class name being managed CSI or leaving it empty. And then we have a persistent volume claim. As I said, in persistent volume claim, one important point: persistent volume should not be in a namespace. It can be in a namespace, but make sure that other namespaces can access it. But because multiple namespaces needs to work with it and make use of it, I left it as I left it at the scope of the whole cluster itself. But the persistent volume claim, this this needs to be at a specific namespace. That's why I put it in the namespace, and then I use the same label for it as I used for my persistent volume. So you see that the labels for the persistent volume and the persistent volume claim are the same. This is needed. And then because here I left the storage class name empty to make sure that I am using the resource that I have provisioned myself, I leave it here as empty as well. I put the name of the volume here. So basically this is the persistent volume name that goes inside the persistent volume claim. Because it is of the type read write once, I leave it also in persistent volume claim to read write once, and then I say that I only need 1 GB. Here we have 8 GB available. Here I leave it 1 GB. The reason it is 8 GB is because this resource that I'm using here, it has only 8 GB available. So make sure of this. So if, for example, you have here 4 GB and you make 8 GB, that's an issue. That would be problematic. And when you have 8 GB here, if you request 10 GB, that would also fail. And after that, here you can see the resources that, for example, if I say kubectl PV, here you can see that I have a persistent volume. This is the persistent volume that has been created here. I will later talk about I wonder why the other ones are created. I know why the other ones are created. The other ones are created because of this stateful set here. I will explain it later when I talk about the stateful set with multiple replicas and then leaving it to manage CSI. the other scenario that I explained here, this other scenario here. So I will explain it later, though they are created because of this reason. Here you can see the persistent volume that has been created. Voila, you see 8 GB, and then the retain policy. Retain basically means that when the pod is destroyed, you keep basically the data. I will show you where it's coming from, and it's already bounded. Alright, here we explain the PVC, and after that I can go ahead and create a persistent a stateful set. So basically the stateful set, how it works, I am saying that this is the pod itself. This is the pod where Postgres is taking the stuff. So I'm creating it with the stateful set. Basically, a stateful set is just like deployment, but for a stateful application. I give it the namespace, I give it a name, a service name, and then I said that, okay, I want to have one replica. This is something tricky here. I will explain it later. If you want to increase it, you need to make sure to change it. Okay, let me open this one here at the other side, and then I will explain. So then I put the match labels the same as the one that I have for persistent volume and the persistent volume claim. You see that they are the same here. And after that I go ahead and create my container. So this one I need to have a pod which will host the Postgres database. So in order to do that, I need to have a container of type Postgres. But this Postgres, I want to explain why we have this init container. Basically, we have two containers inside a single pod. So we have a main card, and we have basically a main application, and we have a sidecar. This sidecar is being used as type init containers. That means first it needs to start, and after that the other one can start. So that's the point. First, let me explain this container itself, and then I will get into the necessity for this one. So I want to have a Postgres. I call it Postgres. Go ahead and make use of this image, Postgres 17.4, the latest version. Pull it if it is not present, and it works on port 5432. And then I said that, okay, go ahead and make use of it. Now all the environment variables for making this Postgres needs to come from config map. I told you I do not have any Kubernetes secret. It's coming from the config map, so that's why I'm saying that, okay, environment from config map ref, and I give the name of the config map. My config map's name is Postgres EMS. And then I want to change the place where the data is being saved. By default, data of Postgres is being saved in var lib Postgres data. I want to mount it somewhere else, to mount data and save it in PG data. And then if we have basically secret values, we can refer to the secret values this way by saying that the secret key ref, give the name of the secret, and then the key of the value that is being saved inside this secret. And then I said I need to mount this container to some volume. So in order to do that, I need to come here. I have a volume. This volume is coming from this PVC. I give it a name, so consider this Postgres DB as a alias for the persistent volume claim that we are referring to. It is here in the claim name. Look at here, it's the same as the PVC name. So I created the PVC. Basically, so the order is like this. You create a PV. In the PV, you say that where you want your data coming, your volume come from. And then you make a volume claim to make a claim to the PV in order to get a persistent volume, in order to get some volume. And then inside your stateful set, basically the configuration file of your stateful application, you say that, hey, refer to that PVC, refer to that persistent volume claim, and call it this one. And then whenever you need to mount it, basically I need to mount it in this container, I refer to this alias that I defined here, and then I say that, okay, this is the mount path, which means this persistent volume claim, which is an Azure disk in our case, mount this part, this path inside my container to this managed disk. Basically that's what it means. Okay, and yeah, and that's it. So basically this is the container, but now there is one point. If you look into the config map, you see that I have a user. My user is called Postgres. Now this user needs to have read access to basically this place. So I think it also read write access. So basically we have this init container, so initialization container, a sidecar starts before this other container. And then we say that, okay, go ahead and execute this command. Excuse me. Go ahead and execute this command in order to be able to write to this specific location. And this is also coming from this alias that I gave here, basically the name of the persistent, a name referring to my persistent volume claim. And I'm saying that inside it, go ahead and allow this path, change the ownership of this path so that we can write inside it. So basically, I'm not sure exactly because I'm not a Linux expert, but this is how it works. This is the purpose of it, in order to allow us be able to write to this path, and only after that the container will be able to run. So this is the point. And after you do this, if I say, if I say here kubectl get all, in the name of the namespace is .NET application, here you would be able to see that this Postgres basically replica set has been created. Here it is. This one has been created because it's a sorry, I said replica set, the stateful set. Because it's a stateful set, the name of its pods are clear. You know, it's not like the other deployments where you have a name of a deployment and then the pod takes you know, attach something to its replica set and then attach some other alphanumerical to its pod name. That's not the case for basically the stateful sets. It's predictable, and it was only one replica, and that's why we have it here, and you see that it's running. Now we can even connect to this by I have put some queries here, basically to be able to connect to this one. And explaining this is that kubectl exec in interactive mode, connect to this pod. Basically this is the name of the pod. Connect to it in interactive mode. It is in this basically namespace, and open a bash script on it. And by doing so, we are now inside it. When we are inside it, we can go ahead and change the user to Postgres user, basically the name of the user that here we have in the config map. So now I'm executing everything with the rights that this user has. And when we are inside it, we can go ahead and list all the databases that exist. We can see that the database PSDB exists, and after that we can connect to it. And here we are connecting. Oopsie, we are basically we are now connecting to it. I think the name is, yep, DB. Now that we are connected to the database, we can go ahead and see that what relations exist there, and I can see that I have the product categories, products, and everything else. And also I can see where data is being saved. So basically this is where the data is being saved. The data is being saved into the path that we have clarified. So because I have put it here, as you see, there is one environment, PG data, and we are saving it here. Now, one important point. We have mounted, as you see here, we have mounted our volume to this path. As soon as we mount the volume to this path, one thing happens is that basically this folder will not be empty, because a lost found folder will be created there. So for example, I can show it to you. So if I connect to this Postgres 0 and in interactive mode and in the .NET application, and then make connect to this one, here you can see that we have the mount path. If I go into mount, I have data, and if I go to data, you see that I have this one. As soon as we make this volume claim, this PV, and we mount it to this path, and then as soon as we make the volume, and then here we mount some container path to the volume, this is being created. And then when we wanted to save data here, basically to this place, it was complaining that this is not empty. So that complaint was coming from Postgres, and that's why I have to make this other path, PG data, and then inside this PG data you see that all the basically files related to our database is being saved. So yes, that's it. This is the point, and then after a stateful set is created, we need to make it as a service. So this service, I make it a cluster IP. Cluster IP is basically the default value. So if you do not mention anything, the service will be of type cluster IP. Basically, again, I have a namespace, I give it a name, and then I use the same label that has been used for the stateful set. As you see, the same label needs to be used. This needs to be the same, and then this one can be cluster IP, can be node port, or can be load balancer. Node port basically means the service makes use of the IP of one of the nodes that you see here. So basically we need to have two port forwarding. One is to forward the request coming to the node from the port that you're listening to the one that the service is listening, and then another one from the service, the port, to the container inside the pod. And then the other one is load balancer. Load balancer means it creates a load balancer, an external IP for you, and with that external IP your service is exposed to the outside one. And cluster IP means that there is no public IP, there is no IP on the node itself, and the service is only available from within the AKS cluster. That means only the services inside the cluster can communicate with it. So basically that's the whole point of this node port and other stuff. So basically I make it a cluster IP because nothing from outside world needs to connect to it. I do a port forwarding, so its listening port means the one that the service will listen to. The service will listen to on port 5432, and the target port means what the container in the pod is listening to is 5432. So this is the port forwarding from service to the container port, and then again the same label. And with that, the service is being created. So again, if you have, if I say kubectl get SVC, which stands for service, and do .NET application, you can see that here we have a service, Postgres service, which is the one that you see here, and as you see, it doesn't have an external IP. Now here you see a Razor page, and this is what the one that I'm going to talk about. So basically, remember this application that we have here that I told you that this is a Razor page application. And oh, I didn't explain everything about this. I will get back to here in a moment. So basically here I have a deployment. Now deployment is basically in order to save some basically in order to create an application, a stateless application. I left it with one replica. I call it the Razor app, and then this Razor app, inside it I have a container. The container is reading from my own Azure Container Registry. This is the address of the Azure Container Registry. This is the image that I'm using, and this is the one that basically I'm referring to. And after that, yes, that's it. So image policy always, so that means always go ahead and pull it. It could be if not present, and then basically it's listening on port 8080, basically typical stuff. So the only point is here, the container is coming from our own container registry. I will explain this in a minute. And then after I create this, it will create the pod, and then I go ahead and create a service to expose this. I created it as a load balancer so that it gets a public IP. So this public IP is coming because of this load balancer, and that's why our application is available on 9.163.53 whatever, and that's why you are seeing it here basically. So yes, that's it. And now about this problem. This problem is coming, the reason that it's not showing it right now is because I have made changes to basically the database, and because I have made changes to the database, I need to publish it again. Now let me explain this part. So everything has been clarified about the structure of my Postgres, of my basically application, and all the resources that is related to Kubernetes. That's all. And then here is the application itself. Then also let me show you a little bit about the infrastructure that I have here. Let me show you the infrastructure. Basically, this is the infrastructure that I have right now. So this infrastructure created with Bicep, mainly with Bicep, the parts that for just velocity, increase the velocity. I had to made it with hand to make it faster. Basically, I have an AKS cluster, I have an Azure Container Registry where I'm putting my images of the application there. So basically this is the images of the application there. Azure Kubernetes Services has access to this Azure Container Registry via some role assignments. So I'm adding the managed identity of AKS as a reader to Azure Container Registry, and also to list, and also at the end I made it a contributor. So basically there are two role assignments. So one of them I think was the reader, and the other one is for making it a contributor. I have a managed disk. The managed disk was the one that was used for making the private volume, and then some DNS zone that is later that I will show you why it is important and for what purpose we are going to make use of it. So basically that's the infrastructure. Currently I have a couple of other managed disks. I will explain when I come to this point. So talking about the storage name class when it is managed CSI. I will talk about this as well. Or maybe I can explain it quickly right now too. So let me tell you one other thing maybe before I go to the application. That is, so having a look at here, kubectl get all.NET application. Okay, so .NET application. Now here you see that I have a couple of other Postgres too. The reason for that is here. If I have one, my stateful set has only one replica, that is fine. I can go ahead and say that, okay, I have a specific volume claim, make use of this volume claim and mount it to my container. That I can do. But now there is one point. If I have multiple replicas, like for instance, I say that I want to have 3 replicas rather than 1, this will not work anymore because I only have one PVC, and behind the PVC is a managed disk, and as I told you, the Azure managed disk cannot be mounted to multiple nodes. It can only be mounted to one node, so it needs to be detached and then attached again. Now when we have multiple replicas, we need to make some changes. We need to say that, okay, I do not create a PVC manually. I would say my storage class is of type managed CSI. Instead of having, let me open the one with one replica set here. So here with the one replica set, we have a volume mount. So I have a volume and then I mounted that. So the volume, I have first created the volume claim, the PVC, and then here I have made it, I have attached it. But here I said, instead of creating the PVC, I give you a template. Whenever it's needed, you go ahead yourself and create the PVC. So basically I say we have a storage class name, it's of type managed CSI, read write once, and then it needs to have 8 GB. So that's the point. So, and this managed CSI, it will enable my AKS cluster to create managed disks whenever it's needed. Read write once, default value is managed disk. So whenever I need to have a persistent volume claim, you go ahead and you create it on the fly for me. Now because here I have 3, you need to go ahead and create 3 of them for me. And after I executed this, these resources are created. So basically this replica set, this stateful set has been created for me, and after this stateful set has been created for me, these 3 pods have been created as well, and in each of them we have a Postgres, and I will show you in a moment in basically in Azure Portal. Now the point is that when we have this structure, we do not have control over the infrastructure, in the sense that these resources are created by AKS cluster and not by us via Terraform or Bicep or with whatever infrastructure as code as we have. So we need to consider the DevOps policies of the organization when we do this. So that's one important point. So whenever you have multiple replicas, you need to go ahead and make use of this volume claim template, and then make use of the name that you put for it. I call it Postgres storage, and whenever you need to mount it, use the name of this volume claim template. Here is Postgres storage. Inside the container I've put Postgres storage, and inside the init container again I put Postgres storage. Everything else has been exactly the same. So here it is, that's it. And again, you need to make a service on top of this in order to expose this replica set. So you can exactly go ahead and make a name for it, and then you use the right label in order to refer to this one. So okay, I see there is one problem here. Let me just call it StatefulSet. Okay, now where do I have app again? Okay, here I have SS, and I have, I think, inside the container. Okay, I use it here, I use it here, I use it there, and I think that's it. Yes, alright, now this is correct. I can go ahead and do kubectl apply dash f, and the name of it is basically this one. Oopsie, this one dash n .NET application error path postgres infrastructure does not exist. Let me see. Okay, is invalid, forbidden updates to stateful for field other than replicas, ordinals, etc. Okay, that's fine. Then let me go ahead, because I don't have anything here. I think that's also the reason that the application was raising an error there. Okay, so this one has been deleted. Now this one has been deleted. Let me see if I can see ahead. Yes, exactly. It was being confused. It was being confused because it didn't know this Razor app. I will explain it in a minute. It didn't know to what it needs to connect to. Okay, that was the problem, because this service, behind this service was, it needs to be the stateful set that has this label. This stateful set already has this label, and then I made another one with replicas, this one, and it also had the same label, and that's why it was confused. It didn't know what to connect it to. And then my connection string, if you look into my connection string, basically here is the connection string. It is connecting to Postgres service. This is the namespace, and then svc cluster local, and then it was listening on this port, and then the name of the database, the name of the username, the name of the password. It shouldn't be here, but because this is just for development and explanation, I'm using it. This needs to be saved as an environment variable inside my GitHub basically workflow, or in my Azure DevOps environment variables as a secret. So, but yeah, that's the reason it was being confused, because it didn't know what to connect to, because it knows to connect to this service, but then the service was being confused to know to use what. So basically that's the reason. But now you see that basically now it's working. If I go to create a new category, I can say, for example, books, and then I say save, and then I can go back to home, and then I can go to a product, and then I can create a new thing, and I call it, for example, catcher in the rye, and then I can connect it to books and then save. And then here you see that, for example, we have beef as a food and catcher in the rye in the books. So basically this is being created. Alright, now that we have this, let me go ahead and explain how this application works. Basically, this is, oopsie, just a second. Alright, so the application, I talked about the model, I talked about the pages, and then also regarding the application itself. I just made a DbContext, so the best thing is that you use a repository pattern, etc., and put mappers, and do not make use of the models as DTOs, because right now I'm using them as DTOs, data transfer objects, but the models that you work with entity framework needs to be different with the DTOs, and then you need to write the mappers, etc. As I said, this is not the purpose of this demo. The purpose of this demo is just to show how to deploy an application into Kubernetes, basically what is happening under the hood, and to explain the resources of Kubernetes, not anything else. Now here we have DbContext option, and then basically DbContext options basically inherit from DbContext. It is coming from entity framework core, and then it will work as an ORM, the object relational mapper, and then you basically in its CTOR, in its constructor, you inherit from you introduce the DbContext options, you give it to the base class, and which means the DbContext, and then for each of the models you make a DbSet, DbSet of category called categorization, categories, and DbSet of products basically. And this is a bad naming, it needs to be categories, because product category is named like a junction table, so this needs to change as well. So basically, yes, this is the DbContext, and then after you define the DbContext inside your pages, you need to inject the dependency of DbContext, and then you can make use of your context with for all the CRUD operations. So context.categories.add, you add it, and the rest of the stuff is being done here. So basically that's the point about the page. And yeah, then there is the dependency injections. The dependency injections are happening inside here. Basically here we only need to inject DbContext. So the DbContext, we call it product DbContext. We add it as builder.service at DbContext, and then we need to mention that what is the connection string. I give it it gets the DbContext options, it goes to DbContext options. We are using Postgres, so you see that it's very similar to SQL Server or Azure SQL. Instead of use SQL, you just use PostgreSQL, and then the connection string can be found in builder.configuration.getConnectionStrings. And when you have get connection strings, if you use the word connection strings here, automatically get connection strings will come here, and then based on the name of the one you give it, you provide it here, it knows that what it needs to work with. So now here I put local Postgres. The reason for that is that first I made a Docker compose. In my Docker compose I made basically a Postgres server available with these values, and then pgadmin. I didn't make use of it, but this one is basically what I needed. And after that I developed everything locally. So if I run it here, I would be able to see it on my local machine. Of course, Docker needs to run. This is very important. Make sure that your Docker is up and running, and after that this will makes it work locally on your machine. So, and after you finish with your implementation and you see that everything is working, so basically as you see that here I have made sure that everything was working. So after that works, you can go ahead and change this to your basically to the one that needs to work in the server, and basically that needs to be default connection 1 or default connection. So basically default connection 1 and default connection both are doing the same thing. You can either put the name of the service, which means my AKS service, and then the port, database, username, password, or you can say the name of the host will be the service in AKS dot the name of the namespace dot it's a service, so svc dot cluster dot local, and then the rest will be the same. So basically that's the point. And after that one is done, you can go ahead and publish it. Publishing is also very simple. Let me show you. We have two options for publishing. I can go ahead and here I can say go ahead and publish. Let me show you that how you can make a new profile. In the profile you say that I want to publish it to Azure, and then you say that I want to publish it to Azure Container Registry. Now here I would stop it at this moment because I don't want to show the subscription and the credentials that I have. I will stop this part. Alright, just a little bit hiding here. So basically here you use your basically resource group, and after that you can, under your resource group, I mean you enter your credentials, and after you enter your credentials you enter the subscription, and then it's connected to the right subscription, and then you can choose the resource group, etc. And under your resource group you can see the Azure Container Registry that we have created. This part is very nice. I like this part. So you can use either Docker Desktop in order to create it, or you can leave it to .NET itself in order to create it, and after that you say finish, and then it will create it for you. The only thing that is important is that here you go ahead and make you edit this tag, and I don't like to use basically latest. I want to always make use of semantic versioning so that I can clearly know what I'm working with. So I'm basically, and after that you say okay, and now it's ready. You can say go ahead and publish it, and then after you publish it, here in your deployment you can go ahead and simply change this version, and basically that's it. Now it's working with the other one. So yeah, that's it. That's all I wanted to say. So for example here I can say games, and then save, and then here I can go ahead to products. Again, I can create something else. I can say Doom, and then here I just go ahead and add it to games. Basically that's it. So this is the whole point of the infrastructure. And now I'm going to show you what has been created for us. Alright, now here we see that what is happening inside our resource group inside here. So with Bicep, we have created a resource group. Inside the resource group, we have a container registry, a cluster, and a DNS zone, and then some managed disks. So these are all created with AKS cluster. Sorry, with Bicep. In my container registry under the repositories, you can see everything. So I think it is under services, under repositories. You can see that I have an application called AKS app, and this is the latest version, the one that we are using, and this is available here. And after that, if we go ahead and look into where is it? Just a second. So yes, that's it. And then if I look into access control IAM, and under basically check access, I can go ahead and say manage identity, and in the manage identity I can go ahead and say Kubernetes, and here you can see that what role assignments it has: ACR pool and contributor. So basically that's it. Also under resource group, remember I told you that if you want to have multiple replicas, at some point you need to make use of this one. So in your replica set, you need to have, for example, 3 replicas, and then here you need to make use of managed CSI so that the AKS cluster itself can go ahead and create basically managed disks if needed for each of the replicas. It creates its own PVC, and it creates its own PV, and it creates its own resource. So basically that is what it's doing. So if I do kubectl get PV right now, you see that I have multiple of them. Actually I have doubt right now. Okay, they're deleted. Okay, see, delete. So reclaim policy delete. Okay, and then basically if I do get PVC, and then I say in .NET-application, you see that I have 3 of them again here. So these PVCs these 3 are coming from this replica set, Postgres SS StatefulSet. So Postgres StatefulSet is being the one here, and the other one was just a PersistentVolume claim. And then what else can I say? Yeah. Basically, why did I mention that? Okay, so this manage CSI. So in order to be able to create resources, AKS needs to have access on here as well. Okay, so let me go ahead and access control IAM. If I say check access, okay, yeah, here we go. Check access on the manage identity on the Kubernetes, and this is it. I made it contributor so that it can go ahead and create resources here. And so yeah, basically that's it. I'm not sure, however, here, I mean, this needs to be changed. I need to double check that, because when I come to my disks, these 3 are created because of this stateful, because of this replica. This is stateful set that has 3 replicas. These 3 are created because of that, and this is the one that we have provisioned ourselves based on basically Bicep with Bicep. So that's the point. And here you see all the size of all of them, etc., etc. All right, now that we have everything, let me go back to my resource group. Inside this resource group, I have the AKS cluster, and then I have the disk, and then that's it. These are all created with what I just showed you. Yeah, and then you saw the final result of the application. You understand that how the replica set works. You understand the services for each of the stateful sets. Sorry, for each of the stateful sets and deployment, you need to create a service in order to expose them, either with ClusterIP or with with basically load balancer or node port. And also not a bad idea also to show you the other resource groups. So if I go back to home and then under resource groups, you see there is a managed resource group created for this AKS cluster, the one here. And if I go here, you see that it has created a couple of things. So one of them is the virtual machine scale set. This is the node pool behind it. It can have multiple node pools. It creates a couple of things like a virtual network and NSG's network security groups in order to manage the infrastructure from the network perspective. And then it creates 2 public IP addresses. One public IP is created for by AKS to work with AKS, and another public IP is created because of our deployment, which is because of our service, which is of type load balancer. So, and then this is the one that has been exposed in our pods, kubectl get pods dash n.net application. Now if you .net application, if I can type it properly today. Okay, now you see that this one, oh sorry, not this one. I think I need to look into the service. Yes, kubectl get service.net application. You see that this one, this is the one that has been created because of this one. All right, and then the other three disks are also created by Postgres. So basically that's it. This is all that has been created by following this. Now I should say that this credit goes to my good friend Mo and myself. We have been working on this repository together, and then let me show you the stuff. This is here, and then we will complete it, and then all the information will be shared later on. So about the AKS, the application, the Razor page, and the one that is related to the infrastructure, the Bicep, and the other stuff. Okay, and then everything is done. You tested everything. You can go ahead and delete the PS1. All right, yes, then that's it. That's all. Maybe I just yeah. I think that's it. There is no other further information. If there are any questions, put in the comments. I will check and I will respond. And with that, thanks a lot for listening. The follow-up one will be published soon by my good friend and colleague Mo, soon enough. Yeah, thank you.